These astounding structures were a stunning testament to the ingenuity of their designers. But there was much more to come from the basic design of the aqueduct.
I think of the Colosseum kind of as a Roman aqueduct that's folded onto itself to enclose space.
It was the arena of the emperor and the citizens of Rome. Over 600 feet across at its widest point and 160 feet high, the Colosseum was home to myriad events. It allowed up to 75,000 spectators to watch great gladiatorial battles in architectural splendor.
The use of concrete is perhaps the most exciting aspect of Roman building technology. The arch is a structural form. It would work with concrete or it would work with rock or masonry, but the Romans took the arch to another level.
The Roman invention and use of concrete for construction led to the development of another use of the arch, the barrel vault.
So instead of a single arch now, you have a room with a series of arches, and so that's three-dimensional, it's a vault. But the Romans went way beyond that. They also took arches and they turned some arches 90 degrees to the first and made intersecting arches. So it's as if you took two barrel vaults and intersected them, and in the middle you have a big open area that's a groin vault. That's a clear Roman innovation.
Impressive though it is, the Colosseum was just a precursor for more remarkable structures to come. Just across Rome, the Pantheon was built in 125 AD. This innovative building would set the standard for centuries to come.
One sees structures like the Pantheon, and the most shocking, breathtaking aspect of walking into a structure like that is open space. What domes afford is interior space unencumbered by column support. The columns, of course, or the walls are on the periphery of the dome, and they're transmitting all the compression force from the dome down through the walls into the foundation.
The roof of the Pantheon was the world's first large dome. It was an unprecedented accomplishment.
You could think of a dome as a series of arches that are all leaning on each other in the middle. But in addition to that, a dome acts as a series of hoops that surround the dome. So what prevents the dome from falling inward, there are arches in plan that are really circles that also can carry load in each ring of the dome as you build up.
The Pantheon has a traditional temple entrance, which opens to the great dome-covered interior. But there's a surprise once inside.
In the exact center of the dome, there's a hole that brings in light. So you have all of these arches that are leaning together to form the dome. And exactly at the center where they all want to lean together, Roman engineers take away the material and build a hole in the middle of the dome.
The 30-foot wide hole in the dome's center, called an oculus, is a huge compression ring made of stone, which in effect is a series of arches forming a circle. The horizontal forces of the dome, which keep the structure stable, converge at the top. It was a daring move by the Roman engineers. The Pantheon was an amazing achievement. But after the fall of Rome, builders would find other spectacular uses for the arch. The Colosseum originally had 80 arches in each exterior level, totaling 240 arches above ground alone. The arch will return on Modern Marvels. By 476 AD, the Roman Empire had fallen. Later, medieval church builders would take up the use of the arch, building primarily with stone. Concrete would not reappear for almost 1,800 years. But the designers of the Gothic era used the arch in ways the Romans could have only dreamed.
The biggest advancement during the Gothic era was the getting away from the barrel-type vault and using more of an elliptical arch or a pointed arch. So from a visual perspective, it allowed the arch to be much taller. And the goal of the master builders during the Gothic era was to try to bring in as much light to the interior of the cathedrals as they could. So the taller they could make the arches relative to the width, they were able to introduce far more area of window.
The era of the Gothic cathedral also saw the use of less massive design elements. Continuing to strive for higher and grander, church builders developed new techniques to maximize their uses of the arch. Gothic cathedrals such as Notre Dame in Paris are lasting examples of the incredibly complex workmanship of the master builders of the time. Cathedral ceilings reached heights of up to 150 feet. As these arches soared ever higher, materials were used more sparingly to allow for this vertical growth, resulting in thinner walls, pillars, and vaults. But with this increase in height, intense forces were exerted by the soaring stone arches and had to go somewhere. The Gothic designers came up with an ingenious solution.
You still have to get the thrust of the arch down to the ground. So how do you do that? That's the real challenge in Gothic construction. And this is where the really ingenious breakthrough comes of building flying buttresses, which are exterior, elevated half arches, really, that carry the flow of forces from the main vault down to the ground.
So as the arched ceilings grew wider and taller, the sides of the building wanted to spread. The use of flying buttresses provided a rock-solid method of reinforcement for the thin cathedral walls.
You can think of it as half of a Gothic arch. So a Gothic arch with a point at the middle. If you take those two sides and separate them, they each want to lean inward. And so they can help to resist the thrust from the central nave that acts between those two flying arches.
Flying buttresses became a very reliable method of building grand structures. But this method required precision. In some buildings, such as Selby Abbey in England, arches have deformed over time due to incorrect placement of buttresses. The flying buttress was perhaps the greatest inspiration of the Gothic era. After the Gothic period, as the Renaissance bloomed, the dome re-emerged from its Roman origins to new and spectacular uses. In 1626, St. Peter's Basilica was completed just a few miles from its predecessor, the Pantheon. The new dome was 138 feet wide. Fable has it that the designers had intended it to be smaller than the Pantheon, out of respect for their forebears. But some modern scholars assert the Basilica's dome is almost 5 feet greater than the Pantheon's. But at 450 feet, St. Peter's was definitely much taller than any existing dome structure.
St. Peter's was significant because it was a very large diameter dome, very tall, dome being the revolution of an arch in over 360 degrees. St. Peter's was a grand application of the marriage of that round shape of the dome with the square geometry of the church below.
But the descendants of the Romans were not quite so masterful with St. Peter's. And within a few centuries, the dome began to crack as the tremendous forces generated by the height of the dome pushed sideways.
The original chain that had run around the perimeter of the dome was not sufficient to do the job. The dome was cracking, and they in fact needed to do additional strengthening work.
The addition of 3 more chains to retain the horizontal force of the arched dome was sufficient, and it has remained damaged but stable for hundreds of years since.